How does a compass work? A compass has a needle in it that has a magnet. And as you know, magnets are attracted to one another. The North Pole is attracted to the South Pole. The South Pole is attracted to the North Pole. Just like with this tiny magnet. In this tiny magnet, two tiny magnets, I have a North Pole and a South Pole, a North Pole and a South Pole. If I put the South Pole next to the North Pole, it's attracted. And if I put the South Pole next to the South Pole, it is not attracted. In fact, it's repelled. In a compass, the needle is attracted to the North Pole of the Earth because the Earth is a giant magnet. It puts off a giant magnetic field. And if you put this magnet in here, that magnet is going to be attracted to the North Pole of the Earth if you're in the northern hemisphere. And you use this then to navigate. If you know which way is north, then you automatically know the opposite is south. And you know. We're going to do an experiment with magnetism. I have a needle, I have a little magnet, a bowl of water, and a little cork that floats. So what I'm doing is I'm rubbing the magnet against the needle. And when you do that enough times, it makes the needle into a temporary magnet. Then you put that magnet on top of the cork, and if everything goes well, the needle should start pointing towards north. Here we go. And that way is north. Very simple. Needle, cork, magnet, water. So it started raining hard outside, and I brought this inside to show you that magnets are attracted to each other. See? But if I tie this string to this magnet so that it can't get all the way to the other magnet, I can do something a little bit different. I can make it float in midair. Here we go. The force is inversely proportional to the square of the distance. And that's just a fancy way of saying that if you move twice as far away, you'll only get 1/4 of the pull. If you get 4 times closer, 4 times 4 is 16, you get 16 times as much strength. It's inversely proportional to the distance. And that means if I just move it just a little bit away, magnetism stops. Playing with magnets can be quite fun. It doesn't have to be anything complicated. I just have some little metal screws here, and I just happen to have a tablecloth with these little bitty squares in them, so I can put these exactly the right distance apart. I then go fishing, and the competition can be anything you want. For example, I'm going to just pick up the one in the middle, nothing else. Oh, failure. And you can do this with your little brothers or little sisters, or if you get good at it, you can do it with your older brothers and older sisters, and then you can mess with them. Because the key is to get in and get out quick, so that you don't have any more magnets getting to the other. See, there we go. You can set them up in different patterns. You can say, okay, you have to get this one on the corner. You can time it. By the way, the ones on the corner are easiest. Don't tell your brothers and sisters that. But the ones in the middle, that's the ones that are very tough. You have to be very quick. Set it up any way you want. There is your game. Have fun. Come back. Have fun.